This meeting is being recorded.
In problem 9, we're asked to predict the products for each of these reactions and then determine which product would be the predominant product. So we see in part A here that we have a asymmetrical diene, right? So if we drew a dividing line here, we could see that either end of our conjugated system would result in the same product. So we only need to consider protonation at one of these locations to give rise to this resonance stabilized carbocation that we see here in the brackets. And I pointed out not only the movement of the electrons that we would see with that green arrow there to generate our second resonance structure, but I also gave them headings here. So this is a tertiary carbocation here, and then we have our allylic species over here. So this would generate, due to these carbocations at either site, where we would have our nucleophilic attack occur from our bromine. So we could add at this site over here on the left, or we could add at the allylic carbocation site down here. And notice that we are at elevated temperature, so our thermodynamic product would form. The more stable, lower potential energy product would be our allylic bromination here, right? This would be our major product. And then we would have our tertiary site be our minor product. Again, this is our thermodynamic product, not the faster product. And then we see over here in part B something similar. We also have this symmetrical diene, so we would only need to consider one end of our conjugated system, right, since they're going to generate the same product. So we have here shown our resonance stabilized carbocation that would be formed after protonation at one of these locations. So we have this resonance stabilized carbocation. We show the movement of the electrons to generate one structure to the other. And then we would have our nucleophilic attack either at this site over here on the left or at this site here. So again, we have a tertiary versus an allylic. And we see that our tertiary site, that will generate our kinetic product. We are at lower temperature here. And if you recall, this is most likely due to a 1-2 addition and that effect of proximity, where we have our protonation and then our addition of our chlorine at in a 1-2 fashion.